What two conditions must be satisfied in order for a sample mean to be normally distributed? Okay, so in order to be normally distributed, remember there's two things that must be. The first is that the parent population must be normally distributed, as well as the sample size is large, so that the central limit theorem can be applied. Question 2. What is the z-score formula for a sample mean that is normally distributed? Okay, so if you remember, in general, our z-score is equal to the value minus the mean divided by the standard deviation. Okay, so we represent that by the following variables: x minus mu divided by, now in this case, remember our standard deviation is sigma divided by the square root of n, because now we have the sample size right there in n. Okay? Question 3. Suppose a normally distributed population has a mean. Question 3. Suppose a normally distributed population has a mean mu10 and a population standard deviation sigma equals 5. So what is the probability the outcome is between 5 and 15? Okay, so I'm going to just write this up real quick so you can kind of visualize this on a normal chart. They say it's normal and we have a 10 as the mean. Remember, this is a z-score, which I'll just write here, of 0. Okay? Now they want to know what is it between 15 and 5. And they also told us that the standard deviation, that one standard deviation, or where z equals -1 and z equals +1, the distance is 5. Okay? And so both of those landed right on one standard deviation away. And if you'll remember from the 68, 95, 99 rule, 68% of this whole underneath is found within plus and minus 1 standard deviation. So the distance here, the distance there, 68%. Okay? Part B. What is the 40th percentile for this population? Okay, we're going to check on the normal probability applet right here real quick to find what that area is. Remember, we are 40 because the 40 is less than half. We need it to only shade this part. And we find our z-score of -2.53 that corresponds to that. So -2.53. Okay? Or excuse me. -0.253. Okay, and we're going to work with that in order to solve our z-score, or our equation, backwards, because we're looking for, in the question it says the 40th percentile, so we're looking for the score, what somebody in the 40th percentile would have scored. And so we have our x, which is what we're looking for, and then minus our mu, which in this case is 10, divided by our standard deviation, which is 5. Okay? If you algebraically rearrange that, you get x equals 5 times -0.253 plus 10. Okay? You plug that into your calculator and you get 8.7. Okay, so that is somebody that scored in the 40th percentile, or an object that is in the 40th percentile. Part C. What is the z-score for an observation of 18.5? Okay, so remember our observation is x. So we have z is what we're looking for, equal to 18.5 minus 10 divided by 5. Okay. Plug that into your calculator and you get 1.7. That is the z-score for an observation of 18.5. The trick on these, all of these, is that you locate what variable you're looking for, and then plug in everything else. D, part D. What is the probability that an observation is greater than 12? Okay, so greater than 12. 12 is our observation, or in other words, 12 is our value. So we're looking for first z-score of 12 minus 10 divided by 5, which is just 2/5, or 0.4. Okay? So we can come over to the normal probability applet. We're going to type it in to find greater than that z-score. Okay? So we have our normal probability applet here, and we're looking for anything that's greater than a z-score of positive 0.4. Since it's positive, we plug it into this box, not this one, and we get a 0.4 right there, which shows us the area, and remember that area also represents the probability, which is 0.3446. E. What is the probability that an observation is less than 8 or greater than 12? Okay, so you can type all that in to the calculator, find the next z-score, or we can use what we already know, and I'll show you how to do that, okay? So first, let's think about how this is going to work. We had our mean of 10, and we just found that 12, this area right here, was 0.3446. So 0.3446. Now they want to know, we also want to add in there what's below 8. And if you look at what's below, and now observe closely here, because we have this distance is 2, as well as this distance. Okay, so an equal distance from the center means that this area is going to be the same as this area over here. So 0.3446. And you add those together, and you get 0.6892, which is the probability of getting above 12 or getting less than 8. Question 4. Samples of size n equals 4 are taken from the normally distributed 2011 sales data. What is the shape of the distribution? Okay, the shape is normal because the parent population is normal. Question 5. Sample size of n equals 40. Okay, so in this case, it is normal again. Normal first because it's from a normal population, but also because the sample size is large, and that implies the central limit theorem. Question 6. A sample size of n equals 4 is taken. What is the probability that the observed x bar is less than 40? Okay, so we're going to take a look here at this z-score. We're going to be doing a lot of z-scores in this lesson. A z-score of 40 minus 45, because remember this is our x, this is our mu, divided by our n, or divided by our standard deviation, which is the sigma, which is the parent standard deviation of 10, divided by the square root of our sample size. Okay, so again, this is sigma and this is n. Okay, you type that into your calculator and you get -1. Okay, so we can come over here to -1 onto the probability applet, and we want to know if it is less than, and so it's actually, that's the standard that it's come, so -1 as a z-score, less than that gives us an area of 0.1587. Question number 7. A sample size of n equals 4 is taken from the normally distributed data. What is the probability that the observed value is greater than 35 and less than 55? Okay, so let's plug in this time. We're going to plug in 35 into our equation. Okay, and as we plug in, and our sample size is still the same, so that was the only thing that changed. So with a 35, when we plug that in, we get a -2. And then what you'll notice here is if you think of the math, if you plugged in 35 minus 45, you get -10. And if we did 55, we get +10. Okay, so the only difference between these two is the negative and positive. So we're talking about between negative 2 z-score and positive 2 z-score. So let's see what area that is. So we're going from negative 2 to positive 2. And we want to highlight what's inside here. The answer is 95, or 0.9545. And that number should make sense if you think about our 68, 95, 99 rule, because within 2 standard deviations is 95% of the results. Question 8. A sample size of n equals 25 is taken from the normally distributed 2011 sales data. What is the probability that x bar is greater than 41 and less than 49? Okay, so this time, let's switch out a few numbers here. So we want to know, first off, let's do less than 41 minus 45 divided by, we still have the sigma is 10, but this time our n is the 25, the sample size that they gave us, so the square root of 25, okay? And as we do that, our answer is actually negative 2 again. And here's the same thing that we saw in the last problem. 41 minus 45 is negative 4. So 49 minus 45 is positive 4. Okay? And divided by this comes out to be 2. You get positive and negative 2. Okay? You can work that algebra out if you like. Now we come over here again, just to re-observe the negative 2 to positive 2. And again, the area is 95. Question 9. A sample size of n equals 25. What is the probability that the observed x bar is greater than 50? Okay, so now we're looking at greater than 50. But our sample size is still 25. So we're going to plug in 50 minus 45. Okay, and I'll just solve this out real quick. On the numerator, you get 5 divided by 10, and then the square root of 25 is 5, which gives us 5 divided by 2, which is 2.5. Okay, so we're going to take our 2.5, and we want to know greater than. So let's come over here to the normal probability applet. We're going to highlight what's above and type in 2.5. Okay, you get an area of 0.0062. Question 10. Samples of size n equals 4 are taken from the right skewed data, 2010 p-phone sales data. What is the shape of the distribution of x bar? Okay, so this time it's right skewed because our normal population is right skewed, and we don't have enough samples to our sample size is not big enough for the central limit theorem to kick in. So it's going to be right skewed. Question 11. Samples of size n40 are taken from the right skewed 2010 data. What is the shape of the distribution? Okay, so this is going to be approximately normal because now, although the parent population is right skewed, we have enough for the central, a large enough sample size for the central limit theorem to kick in. So this is going to be approximately normal. Question 12. The central limit theorem. The central limit theorem says that as the sample size gets larger, the distribution gets closer and closer to normal. Question 13. A sample size of n equals 4 is taken from the right skewed data, and you want to know the probability that the observed x bar is less than 35. Can you compute this probability using the normal probability applet? Okay, so we cannot compute this using the normal probability applet because the distribution is not normal. And that's why it's called a normal probability applet. Only works for normal distributions. Question 14. A sample size of n equals 36 is taken from the right skewed 2010 data. What is the probability that the observed x bar is greater than 36.5? Okay, so this time our numbers have switched just a little bit. So we're going to erase these. Remember, for this whole section, we're using the same equation where we have x minus mu divided by sigma divided by square root of our sample size. Okay, so in this case, we have our value that we're looking at is 36 0.5, and our mu is the mean, which is 40, divided by our sigma, which is the standard deviation of the population, of 12, and the square root of our sample size, which in this case is 36. Okay, and as you plug that into your calculator, you come out with negative 1.25. Okay, and we're wondering about, or excuse me, not 1.25, 1.75. That's better. Okay, 1.75, and we're wondering what is the probability that it's greater than that. So in order to find that probability, we can use the applet to find out what is above. So we're wondering what is above negative 1.75. Okay, and above is about 95.99. Question 15. A sample size of n equals 36 is taken from the right skewed data. What is the probability that the observed value is between 37.5 and 42.5? Okay, so let's work through these. So first off, our first value that we're looking at is 37.5. Okay, so 37.5 minus our mean divided by our standard deviation of the population divided by the square root of our sample size. Okay, so in this first one, it's negative 1.25. And then 37.5, we're going to check now, 42.5. And again, notice the pattern that the difference here is the same, just the opposite sign. So when you type that in your calculator, you'll just get the positive 1.25. So if we want to know what's between those, we can plug that into the probability applet, selecting the center area, and typing in 1.25. Okay, our area is 0.7887.